Tutorial 5, Question 1. Given the following marks, find the mean, the mode, the median and the standard deviation. First thing to do with data of this sort is to sort it in ascending order. Now we've put it in ascending order, to find the mean, we will add all the numbers together and divide by the number of separate values. So we add the numbers together, we get the value of 1304. There are 21 separate numbers, so 1304 divided by 21 gives us 62.1. As a quick sanity check, 1300 divided by 21 is the same as 130 divided by 2, which is 65. So an answer of 62.1 is about right. So there's the mean. For the mode, we look for the most common value. We can see here that the mode is going to be 61. For the median, you look at the middle value, which is the 11th value, which is this one here. So you can see that the median is going to be 63. And finally, for the standard deviation, we need to take the mean away from each of the values in the data set, square that value and add them all together, and then divide by the number of separate values. That will give us the variance. We take the square root of the variance to give us the standard deviation. The sum of the squares of the differences is equal to 2745. The number of individual numbers is 21. So 2745 divided by 21 is 11.43. This is about 3000 divided by 20, which is about 300 divided by 2, which is about 150. The square root of 144 is 12, so we're sort of in the right place. We can be reasonably confident in that value. And the answer is 11.43. Question 2. Given the following group data, find the mean, the mode, the median and the standard deviation. In questions of this sort, it's always a good idea to draw a quick sketch. So there's a sketch of our data. The classes go from 40 to 49, so the middle of the class is going to be halfway along there, which is 44.5. The next class is 54.5, 64.5 and so on. The next thing to do is to create a table. The mid-class value we'll call x and the frequency is f. So we need the sums of all of the x values, all of the f values, all of the f times x values and all of the f times x squared values. So we'll do the table, and these values at the end here are the sums. So the mean is going to be sigma fx over sigma f. So that's 1324.5 over 21, which gives us 63.07. 1300 divided by 20 is going to give us 65, so we can be reasonably comfortable with that value. So our answer for the mean is 63.07. For the mode, we're going to use this equation, where L is the lower class boundary, L is the frequency difference at the lower band, U is the frequency difference at the upper band, and C is the class value, which either goes from 64.5 to 74.5, or if you'd rather, goes from 64.95 to 74.95. Either way, it's a value of 10. So if you put those values into the equation, we're going to get 59.5 plus 4 over 4 plus 3 times 10, which gives us a value of 65.21. Let's just check that. 4 over 7 is about a half. A half times 10 gives us 5. 59.5 plus 5 is 64.5. So a value of 65 looks okay. To find the median, we need to find a value of an imaginary balancing point here. I'm going to call the value on the left hand side A, and the value on the right hand side is going to be the frequency minus A. So we're going to add the frequency of the classes on the left hand side of A to the frequencies of the classes on the right hand side of A. So we're going to get 3 plus 4 plus A is equal to 8 minus A plus 5 plus 1. Three plus 4 is 7, 8 plus 5 is 13, plus 1 is 14, so we can simplify that slightly. I'm going to take 7 to the right hand side, and I'm going to take minus A to the left hand side. So I've got 2A is equal to 14 minus 7, so 2A is equal to 7, so A is equal to 3.5. Right, we'll put those values into the equation. So it's L plus A times C over F, where F is the class frequency, giving us a value of 63.88. As a sanity check, we've got 3.5 times 10, which is 35, 4 eighths are 32, so we're going to add slightly more than 4 to 59.5, so 63.88 is about right. So the median is 63.88. And then finally, to find the standard deviation, we need sigma fx squared over sigma f minus sigma fx over sigma f, all squared. Now remember, this value here is actually the mean, and we know the mean is 63.07. The mean is 63.07. So if we put those values in, we get a value of 10.8. Question 3. The time taken for employees to complete an operation was recorded on 80 occasions. Let's just check that. 4 plus 8 is 12. 12 plus 14 is 26. 26 plus 22 is going to be 48. 48 plus 19 is going to be 67. 67 plus 10 is 77. 77 plus 3 is 80. So that's the data stacks up. Okay, so the class interval. Well, to find the class interval, you can take any class and subtract the previous one. So before we answer the questions, let's draw ourselves a quick sketch of what the data looks like. The class interval is the difference between any two adjacent classes. So we can subtract 12.5 from 13 and we'll get 0.5. We can subtract 11.5 from 12, or 11 from 11.5, or 10 from 10.5. Whichever one we do, we'll get the value of 0.5. So the class interval is 0.5. For the lower boundary of the third class, we go 1, 2, 3, there's the third class, and the lower boundary value is halfway between 10.5 and 11, which is obviously going to be 10.75. The upper boundary of this class is 12.25, so the upper boundary of this class is going to be 13.25. And there's the boundary of the 7th class. Question 4. For the data given in question 3, find the mean, the mode, the median and the standard deviation. Well, let's start with a graph. And then we'll create the table. Notice this time we're not using x's, we're using t's, because we've got a variable which is time in minutes. Here are our values, and here are the sums of the rows. Sigma ft over sigma f to give us the mean, which is 11.5. This is 900 over 80. 900 over 90 will be about 10, so 900 over 80 is likely to be slightly larger than that, so a value of around 11.5 would seem reasonable. So there's our mean. For the mode, we need to use the following equation. L is the value at the lower boundary. L is the difference between the frequencies on the lower boundary, which is the difference between 22 and 14, and U is the difference between the frequencies on the upper boundary, which is the difference between 22 and 19. So that gives us 22 minus 14 is 8. 22 minus 19 is 3. So it's 11.25 plus 8 over 8 plus 3 times 0.5 is equal to 11.61. Let's just check that. This value is about 2/3. A half of 2/3 is a third. A third added to 11.25 is slightly bigger than 11.5. So a value of 11.6 is probably alright. So we'll put that as our answer. The mode is equal to 11.6. For the median, we need to find a value here such that the sums of the frequencies on the left hand side are equal to the sums of the frequencies on the right hand side. We'll call this value here A. So we're going to get 4 plus 8 plus 14 plus A. 4 plus 8 plus 14 plus A is equal to A minus 22 plus 19 plus 10 plus 3. So let's write that out. 4 plus 8 plus 14 is going to give us 26. 22 plus 19 plus 10 plus 3 is going to give us 54. We'll take the minus a onto the left hand side and the 26 onto the right hand side. 54 minus 26. 54 minus 26 is going to be 28. So a is going to equal 14. Put those values into the equation. We've got 11.25 plus 14 times 0.5 divided by 22 gives us a value of 11.57. Let's just check that. We've got 14 times a half is 7. 7 over 22 is about a third. Adding a third, call it 0.3 to 11.25 is going to give us about 11.5, so that's okay. The median is 11.57. And then finally, for the standard deviation, we need to use this equation here. Notice we've got t's now instead of x's. This value, remember, is the mean, so we can just use the mean. And sigma ft squared we've got in the table here. And sigma f we've also got in the table, which is there. So we'll put those values into the equation, and we get a value of 0.72. Question 5. Components are machined to a nominal diameter of 32.65. A sample batch of 400 components gave a mean diameter of 32.66 with a standard deviation of 0.02. For a production of 2,400 components, calculate the limits between which all of the diameters are likely to lie. Now, for our purposes, we can say that the entire population exists between plus or minus 3 sigma of the mean. The values are going to lie between 32.60 and 32.72. That's to say the mean plus 3 times sigma and the mean minus 3 times sigma. So all of the components will lie between those two values. Part B. How many acceptable components are there if the lower bound is 32.62 and the upper bound is 32.68? Well, let's draw a normal distribution curve. 32.66 is the mean, 0.02 is the standard deviation, so it's going to go 0.66, 0.64, 0.62, 0.66, 0.68, 0.70. So 0.68 is the upper value and 0.62 is the lower value, which means we've got 34% of the population above the mean, 34% of the population below the mean, and another 14% of the population below that. So we've now got 34 plus 34 is 68, plus 14 is going to be 82% of the population. So 82% of the population is acceptable. 82% of 2,400 gives us 1,968 acceptable components. And that's the end of tutorial 5.